while ago, I came across this video series by Ben Eater, and in this series he shows you how to construct a computer using logic chips on breadboard. Inspired by his design and a few other guys on YouTube, I thought I could try and construct my own machine, and a few weeks back I actually did, and it works. Even though I didn't record any videos while I was constructing the machine, I thought it should be still cool to try and come up with a series that shows you how I came about with the design and how the machine actually works. As it turns out, my video editing skills are kind of non-existent, so I'll be using the only tool I'm pretty good at, and that is
PowerPoint.
let me just start the series.
Now, before I start talking about the computer's architecture and the various circuits I've used in my computer design, I thought I should first cover the basics. So let's take a simple example of this circuit. Our prime focus is going to be on the switches. So this is what is called a normally open switch. Since the circuit is normally open, when you push the button, the lamp turns on. You could also get something called a normally closed switch, which would be something like this. So normally the lamp is on, and when you push the button, the lamp actually turns off. And a good example of this kind of a switch would be the switch that controls the lights in your refrigerator. So when you actually when you open the door, the switch is released and the light turns on. When you close the door, the switch is pressed and the lamp turns off. You could combine these two switches and get something like this. So this is a single pole double throw switch. You could also use it to control two different circuits. So in this case, I can switch between two different lamps. Now the relays I'm using in my computer are this exact same thing. The only difference being that instead of powering it with my finger, I am actually using an electromagnet. So to operate the relay, I just have to power this electromagnet with a separate 12 volt DC supply. Now, since the rest of the system is also running on 12 volts DC, I can actually use the same power supply everywhere. So something like this. And this is the image of the actual relays I'll be using. Not this exact brand, but this is what it looks like. On the bottom you have 5 terminals. Let's put a label on them. So 2 for the coil, 3 for the switching contacts. Quite easy. And now regardless of where I use these relays, one terminal of the coil is always connected to ground, or in my case it's the negative terminal of my DC supply. And since that is the case, I can actually simplify this small relay symbol so that making circuits becomes easier, at least on paper. So instead of drawing the complete coil, I just replace the coil with just one arrow, and that's it. Now the second component I'll be using in my computer is a diode, and this is what it looks like. I'll be using one N4007 rectifier diodes. And while the physics of this device is actually quite complex, and there's a lot of maths you can actually study, you can actually go through, but for the scope of my project, all you need to know is it's got 2 terminals. If the voltage at the anode is higher than the voltage at the cathode, then we say it's forward biased. So suppose we put it in a circuit like so, and I'll mark the polarities. So in this case, the anode voltage is actually higher than the cathode voltage, so it's forward biased, and that's why the lamp is actually on. Since the diode in forward biased mode actually acts like a short circuit or a closed switch. If the diode is reverse biased, that is if the cathode voltage is higher than the anode voltage, in that case the lamp actually turns off. So the diode is actually acting like a check valve that allows current to flow in only one direction. Now the third thing I'd like to cover in this video is the logical convention. Now all computers are basically mathematical tools, and they work on some number system. So if it's a digital computer like any other computer processor in our modern world, it will be working on the binary number system. But if you think about it, binary number system is just a set of symbols. So 0 and 1 is just a symbol. You actually have to associate some physical quantity with this symbol in order for the computer to actually use it for computation. Now, since our computer is being powered by electricity like the rest of the processors in this world, we'll be using voltage to represent the zeros and ones. So this is the logical convention. So a zero is being represented by any conductor that is not connected to 12 volts, so it is not connected anywhere, and a 1 is being represented by the conductor being connected to 12 volts. So if you want to know if what is the logic level at a specific point in your processor, then you just either add a lamp to see if it turns on or not, or you put a voltmeter and check if it's 12 volts or not. If it is 12 volts, then it's 1. If it's not, then it's 0. And that's basically it with this video, at least. In the upcoming videos, I'll try and come up with simple circuits that you could make using relays and diodes. Till then, you could like, comment, share, subscribe, the works, whatever, and we'll see you in the next video. Thanks for watching.